I put out a video yesterday that gave a quick demo of using this application, RotoWorkshop.com, and showed some of the data that was used in the paper and exactly how you use the application to generate the models that we discussed in the paper. The one thing that the application does that I did not show, which I wanted to show now, is some of the regression models, in particular just linear regression and ensembles of stumps that for regression. So here I'm going to do that quickly. I thought I would use some other data that might be interesting that I have sitting around, and that is predicting quarterback points in fantasy football for week 14. So I have a data set here. It's from it's NFL scraper data, and what it has is the points scored by quarterbacks, and I think the games go back to 2009, along with information from the Vegas lines, so home and away, spread, over under, and then 8-week averages of their passes, completions, passing air yards, and then data about rushing as well. Okay, so I'm going to quickly build a model from this. So as before, I pick which column I want of the data I want it to build a model to predict, and it's the points part. And now when I click on this, if you remember from the last video, it suggested either linear logistic regression or a stump ensemble classifier, but it can tell from looking at the points column that this is, there are a lot of different values of points, and so you probably want to use regression for this, some type of regression model. So let's start with linear regression. If I click on that, it builds a model. You can see at the top the fit, so it has an R squared, and also I give the R the correlation as well. And actually this is really nice in that we have enough data that the R squared out of sample and the test data is actually pretty close to the in sample data. So that's a nice change compared to what we saw in the earlier example. If you look down below, you can see some of the parameters of the model. It has, you can see that home and away, so has an estimate here. The parameter that it uses on that is it increases the predicted points by 0.5 when they're playing at home. And in this column, I mentioned last time that for regression there's an additional column, and that gives the standard error. And when the estimate is more than twice the standard error in absolute value, that's going to tell you that it has a p-value of the p-value that is non-zero is in the range where it's likely that's statistically significant. So looking through these quickly, you can see that home and away, it wouldn't be statistically significant, that particular parameter. Spread, on the other hand, is. Over under is. Passes are not. Number of completions is sort of right on the borderline, a little bit under the arbitrary line that we use for statistical significance. Passing yards and air yards are not. Passing touchdowns are not. Actually, the last one, which you can't see, it's just at the bottom of the page here, is rushing touchdowns actually is statistically significant. So with that, let me go in and grab week 14 quarterback data. So this has all of the quarterbacks, at least all the ones that have played for 8 weeks, so that I can put these numbers together. I need to do something more sophisticated if I wanted to do the other quarterbacks. But all of their parameters, I just don't know their points. So now I click on predict. Choose which model I want to use. Use the points model, the linear model, and let's sort these. So it has Patrick Mahomes at the top by quite a bit, maybe not surprising there. And then Ben Roethlisberger. I mean, you can see Patrick Mahomes has a massive over-under 53, although actually Drew Brees is even higher. And it likes all the rushing yards from Patrick Mahomes, and of course these huge passing numbers right here. Okay. So anyway, looking through the rest of it, Drew Brees, Cam Newton, Aaron Rodgers, Deshaun Watson, Tom Brady, Phillip Rivers, Mitch Trubisky, and so on. These look like pretty reasonable estimates. And in fact, this is the kind of very basic model. I think that at least this is probably the first model that I would try if I were going to do these kinds of predictions. This conventional wisdom suggests that the Vegas lines are important, and that say the last 8 weeks is probably a reasonable sample size for estimating how much passing and rushing the player is going to do. Okay, so that's that one. Let me go back to this and let's see instead what it looks like if I build a stump ensemble model. So I want to predict the points. This time I'll choose an ensemble of stumps. Here's the model. Interestingly, this model, the stump model, it actually has far fewer parameters. So the linear regression model included, every single parameter, every column of the data was included. The stump model actually only wants to use 5 of them. After that, it doesn't feel that the additional improvement in error on the training set is worth adding another variable. So it only uses the following. It has over, under, and spread, both of which were statistically significant in the example that we looked at. Completions, that was one that was on the borderline. And then it includes rushing yards and passing yards, which were not statistically significant in the other model, though the model does include them. So we can look at these plots once again if you want to see what the estimates are. So with passing yards, you can see that there's a substantial improvement up to from below down this 1,200 yard area up to 1,600. Again, this is over the last 8 games. So this is once you get slightly over 200 yards per game, you get up into this 20-point estimate. But then those that are way up here, getting close to over 2,500 yards, it jumps the points up a lot. So that's passing yards. We can look at what is the impact of the spread. As the spread, so more negative spread is a heavier favorite. So if you're over a 4-point favorite, it's going to increase its estimate. We can look at the over/under. Here it's a very simple model. It just gives a bump to those within that are above 45 or above in the over/under. So it doesn't see any need to separate that further. It certainly doesn't look like a straight line. There's just a jump up when the over/under is above 45. Okay, we can do quickly look at the others. Rushing yards, it has a few steps in it. And completions, here just a straight jump. Once you have about what is that? About around 30 completions per game, it gives you a bump up in expected points, which is all right. Okay, so now we can go back to this. We already did the prediction using the linear model, and now we can do the stump ensemble model instead. So click on that, and we'll see. So one thing you'll notice right away is that there aren't as many values. The linear model is going to give a different prediction to almost every single player, but with these ensembles of stumps, some players are going to end up in all the same buckets, so they're going to end up with identical predictions. So this is just actually, we saw this last time with the classifier as well. The stump ensemble model was less discriminating, and that's true here as well. So it puts Patrick Mahomes, Russell Wilson, and Deshaun Watson into the top bucket, whereas before we had Patrick Mahomes all on his own. This model likes Russell Wilson and Deshaun Watson as well. Patrick Mahomes is a bit above the other two, and then Russell Wilson, Deshaun Watson next. But then we have this large group after that, 1, 2, 3, 4, 5, 6 quarterbacks that all have an identical prediction. So Breeze, Rivers, Newton, Brady, Rodgers, and Roethlisberger. So once again, the numbers look pretty reasonable. Cousins is surprisingly low to my eye, but again, actually, if you look at the raw estimate, it's not a huge difference. It's only predicting 0.4 below. So in general, these are pretty conservative estimates as well. Nobody's up in the 23 range. Nobody's down at 12. That's something that's maybe surprising. Maybe you'd think the fancier machine learning method would be one that is making crazier, more outlandish predictions. But in fact, these particular models are, at least the examples we've looked at here, they're quite conservative. They would need a lot more data to start making wilder predictions. Okay, so that's it for this. Thanks for watching.